Alright, how you guys doing? This is Mr. Muscarella coming at you, and we're going to take a look at the last piece of inverse functions, and that's part 4 here. Finding inverse functions and proving functions are inverses, and this is using algebra. Parts 1, 2, and 3, make sure you check those out in the previous video if you have not seen those already. Pretty straightforward stuff. Now let's take a look at our only example here. Check it. Find the inverse of 1/2 x plus 5, then verify the function you came up with is inverse. So, first thing we gotta do is find the inverse. Now there's 4 pieces for finding the inverse, and right here if you notice it says f of x equals 1/2 x plus 5. So what we've got to do is change the f of x to y equals. So we're going to have y equals, and then just 1/2 x plus 5. Now the second step, after we write it as y equals, we're going to switch the x and the y. So the x is going to go on the left where the y was. We'll have 1/2 y plus 5. That's it, the big switch. Third step, solve for y. So we're going to start by subtracting 5 on both sides. So we'll have x minus 5 equals 1/2 y. Now this is where you have to really be careful with the arithmetic, because some people make this common mistake. Right here, to get rid of the 1/2, this term right here, what's the reciprocal of 1/2? Well, that would be 2, so you have to multiply both sides by 2. So times 2, but you have to be really careful here, because that next step, when you do that, you're going to have 2 times x minus 5 times that whole quantity is going to give you the value for y. So make sure you distribute correctly. 2 times x, 2x. 2 times minus 5 gives you minus 10. Now, the very last step, so those are our first 3 steps. Our very last step is to write it using function notation. So I can't use y equals, and I can't use f of x, because f of x was my original function. So the way that you write inverse notation, you're going to write f negative 1, our variable was x. F negative 1 of x equals 2x minus 10. And that is going to be the inverse of our function f of x equals 1/2 x plus 5. So that's the first piece. Now the second piece, what we have to do is we're going to come up with a series of 2 substitutions we're going to take. Now the first substitution is going to involve taking the inverse function and plugging that into the original function. So that's going to be like our setup here on the left. F of f inverse of x equals 1/2 2x minus 10 plus 5. So we're going to do that substitution. Our other substitution is going to come from taking the original function f of x and substituting that into the inverse function. So we're going to go through that algebra, and in both cases, if these are inverses, we should end up with x at the very end when we do all the arithmetic and the algebra involved with that. So let's kind of see what we end up with here for each one of our pieces. Now, in both cases, after I make my substitutions, when I'm done performing my algebra and my arithmetic, hocus pocus, shazam, I end up with a value of x in both cases. Now, if this is a case where you do end up with x when you plug the original function into the inverse and the inverse into the original function, then these 2 functions are verified to be inverses. Now that's not enough. We can't just do that algebraically. We also have to write a sentence that justifies our reasoning. And this is what your sentence should look like. So when you're done, be sure you write a sentence that says the following. Since f of f inverse of x equals f inverse of f of x equals x, f of x and f inverse of x are inverse functions. That's all you have to do for it. But be sure that you write your sentence correctly, because you're going to have to justify your answer. Just writing all this algebra down doesn't get you all of the points that you will need. You'll need to make sure that you have a sentence that justifies your reasoning. Alright, that's it for this example. Peace.